Today, at the most crucial moment in this whole story, Hubble is going into safe mode. Not for a day for maintenance, not we'll check later. Right during the window when 3i Atlas should be at its best. This is the moment when science usually has no room for error, when you've already calculated everything, aligned everything, synchronized everything, and all that's left to do is watch and record. The window was narrow, too narrow to allow for chance, and too delicious to miss if you wanted to hide anything. A few hours before the peak approach, a network of ground-based observatories operates almost non-stop. Europe, Chile, Hawaii, the Canary Islands, South Africa. Everyone is monitoring the object, comparing photometry and tracking the structure of the tail. Hubble is also on the agenda, not because it's the most beautiful, because it provides a reference point, above the atmosphere, without air turbulence, without weather interference. And then just minutes before the key shot, a dry announcement came over the back channels. HST entered safe mode. That's it. No filming, no spectra, no series. You can explain it to the uninitiated as normal security all you want, but those on the inside hear something else. We turned off the only device that can't be justified by clouds. The official line emerges quickly, too quickly to be agreed upon on the fly. It's the standard line. The telescope has entered safe mode. Engineers are analyzing. The scientific program will be restored. If you read this as a typical press update, everything sounds normal. Hubble is old, the electronics are finicky, the security is strict. This has happened before. But this time, the coincidence doesn't look like a glitch. This time, it looks like a solution, because safe mode doesn't trigger somewhere during the day. It triggers at a specific minute when the observation line converges at a single point. And also because an hour before the shutdown, strange things start happening on the ground. Not a failure of one station, not a bad calibration. Strange things happening simultaneously across multiple teams. At first, it looks minor. On one telescope, the object's image seems to flip for a split second, as if the autofocus has lost its bearing. On another, the spectrum shows a brief dip, as if someone flipped a shutter. Normally, such things are attributed to technology, but there's one detail. The dips coincide in time, down to the second, on different continents. When independent instruments blink in sync, you run out of comfortable explanations, because the instruments don't communicate with each other, and the atmosphere over Chile and the Canary Islands doesn't breathe in sync. And at that very hour, almost as a mockery, an official phrase from NASA appears. Nothing unusual, standard safety procedures. This phrase, by itself, proves nothing. But against the backdrop of synchronous anomalies, it sounds anything but reassuring. It sounds like a lid being slammed shut with a hand. Within scientific chats, simple arithmetic begins. How much data do we have from the ground? What are we losing without Hubble? Which parameters are lost forever? Because such flybys don't happen again tomorrow. If it's an interstellar object, it doesn't circle around us, waiting for us to sort out the bureaucracy. When Hubble is turned off, the chance to compare the structure of the jets without atmospheric noise disappears. The chance to refine spectral lines, which from the ground are obscured by spurious artifacts, disappears. And it is at this point that what is called strange pattern telemetry appears. You won't see this officially. Officially, you'll only see that a deviation has been detected in the system, the telescope has secured itself, the team is in contact, but in closed logs, everything always looks rougher. There's time, there are parameters, there's a sequence, and if you know how to read such logs, you see not a fairy tale for the public, but a chain of cause and effect. The strangeness begins with the fact that entering safe mode is initiated not by a single alarm flag, but by a combination of them. Several subsystems simultaneously signal as if the telescope were simultaneously scared of different threats. It's like a fire alarm that suddenly says, smoke, heat, gas leak, door open. All at once, in 1 second. This happens when something truly catastrophic happens, but then you have traces, degradation of parameters, gradual deterioration, precursors. But here, there are almost no warning signs. It's as if the system received an external impulse that triggered various sensors simultaneously. The most unpleasant thing about this picture is that it doesn't resemble aging. Aging is dirt on the contacts, noise in the channels, and slow drift. This sounds like a command to step back into the shadows, and it works perfectly at the right time. At this point, naturally, a call begins at NASA, not a press call, the kind where there are no smiles or mincing words, the kind where they speak briefly and to the point. The first thing they do is curb the dissemination of raw information, because raw logs aren't newsworthy, they're spreadsheets, where every column can raise 1,000 questions. The second thing they do is look for confirmation. Has anything similar been observed on other platforms? On ground stations? On space monitoring satellites? On navigation networks? And here's where the second nail in the coffin comes in. Because at the same moment Hubble went into shadow, several independent observers recorded a brief jump in the brightness of 3I/A TLAS. The jump isn't huge, not a supernova-like explosion, but it's large enough to be noticed by different cameras at different settings. And the strangest thing is that this leap repeats itself, with an interval, with the same step. You can explain one flare as a gas release, you can explain two flares as uneven rotation, but when the flares start to form a rhythm, it starts to smell not of ice physics, but of an algorithm. This is why a strange pattern in telemetry is perceived not as a boring technical term, but as a red flag. A theory is brewing inside. The telescope detected something that its defenses interpreted as a threat. Not because it broke down, but because it saw a level of influence it wasn't prepared for. In a normal story, this would have been the end. The telescope shut down, the engineers fixed it, and everyone went their separate ways. But there's an object here that doesn't just fly by, it acts like it's checking to see who's looking at it and how. And if this thought even once enters your head, you can no longer unsee the coincidence, because there are too many coincidences. Windows close precisely where the purest observation should be. Synchronous blinks appear precisely when the structure needs to be captured, and as if that weren't enough, suddenly cropped graphs are starting to appear in the public domain. Not the actual logs, but a screen grab, a couple of lines, a couple of timestamps, without context. These leaks almost always look the same. They never prove everything. They always prove one thing. Someone inside is nervous and wants at least something to come out, and so the viewer is shown something simple. Second-long spikes in one channel, a short series of pulses, then silence in safe mode. On the surface, it's nonsense. To the layman, it's just noise. But for those who have been watching telemetry for years, it doesn't look like noise. It looks like an event signature. The most disturbing thing about this signature is that it resembles an external kick, not an internal glitch, and it coincides in timing with the very same series of flashes on the object. Then the struggle for interpretation begins, because there are two paths, and both are bad. The first option is to admit that the old telescope simply suffered a rare malfunction at the same time. Then you'll need to explain the synchronicity of the dips on the ground and the recurring rhythm of the object's activity. The second option is to admit that the telescope shut down due to an object-related disturbance. Then you automatically open the door to questions that can't be answered by standard procedures. And that's precisely why the first path is publicly chosen. It's simpler, it's safer, it doesn't change the worldview. But inside, no one truly believes this simple picture. Because inside, there are people who know the value of chance. They know how often devices break, and they know how rarely a device breaks at the precise second needed to see the most important thing. That same day, several teams begin reassembling the puzzle from what remains: ground-based images, radio observations, photometry, amateur footage, and very quickly they realize something else. Without Hubble, the clean line disappears, but another advantage emerges. Earth has many eyes, a lot of eyes, and if an object really did something to turn off an orbital telescope, it can't turn off all of them. Not in a second, not without a trace. And now the real hunt begins. Not for a sensation, but for time. Because the next window is already closing, and the object is already on the way out. But before he goes, he has one more chance to prove himself, and we have one more chance to figure out what exactly turned off Hubble. Because safe mode isn't the end. It's a signal, and a signal always means one thing. Something has happened in this system that can't be ignored. And when you understand this, you are left with only one question. If an object could force humanity's most famous telescope into shadow at exactly the prime hour, what will it do next when we start looking more closely? An hour into safe mode, something happens that always happens when the official narrative is too smooth. People stop believing the words and start believing the timestamps. Not what they said, but when it worked. Internal channels quickly split into two camps. Some stick to the same old explanation: age, electronics, security. Others don't argue out loud, but do their own thing. They download everything they can and compare seconds. Because seconds are more important here than meaning. If an event coincides with something external, it's obvious. If it's random, it will dissipate like smoke. But it didn't dissipate. On the ground, a mosaic of independent stations is already being assembled. Photometry is being integrated into a single scale. Spectra are being calibrated. They're looking not for beauty, but for repeatability. And at some point, one of the operators writes briefly, without emotion, the way people who aren't in the mood for drama write. We have a match on 4 platforms. The peaks are at exactly the same moment. At first, everyone reacts as usual. They look for an error. They check the GPS synchronization. They look at the network log. They suspect that someone has adjusted the time and messed up the scale, but the verification doesn't ruin the picture. On the contrary, it makes it worse. 4 sites, 4 different teams, 4 different data paths, and the match isn't roughly identical. It's as if someone had placed a marker. The next step is even more unpleasant. They overlay these peaks with Hubble telemetry, the part that was there before going into safe mode, and they see something else nearby. Just before the shutdown, a series of short bursts appears on one of the channels that no one normally watches. Not the main, not the beautiful one, but the service one. The one that's just in the background. And this background noise suddenly ceases to be background. It acquires a rhythm. Several pulses, equally spaced in time, then a dip and a retreat into defense. It looks like an event signature, not a breakdown. A breakdown rarely ticks evenly, like a metronome. More often, a breakdown squeals, trembles, and spreads. Here, it's the other way around. It's as if something first touched the system several times, testing its reaction, and only then delivered the blow, after which the defense did what it was trained to do. At this point, a word usually pops up that no one likes to say out loud. Interference. External influence on electronics. Something that can be called by 100 different names, as long as it doesn't sound threatening. The only problem is that Hubble has decades of experience, and the statistics for such events are well known. There's no room for rare coincidences at precisely the right moment. When someone cautiously types, "What if it's related to the object?" in chat, they rarely get a response. Not because the idea is bad, because at that moment everyone understands the value of the phrase. If it's connected to an object, then the object is capable of influence. If it's capable of influence, then we're not just observing, we're participating. And here, we have a different kind of leak. Not a graph, not a screenshot, but a fragment of an internal description of the failure, rewritten in human language. It looks like a sequence of false alarms, as if the system received a set of signals that contradicted each other. This formulation hurts more than the numbers, because the numbers can be dismissed as noise, and contradictory is when the sensors seem to see different realities simultaneously. It was as if the telescope had been presented with several bad case scenarios and forced to choose the safest one, and it chose the shadow. That same evening, a strange cleanliness in the public data begins to be noticed in the messages. Too few details, too careful language, too quick, everything under control. This is what they write when they want to close a topic before it becomes a question. Not a scientific one, but a political one. Because Hubble is a symbol, and symbols shouldn't appear vulnerable. But science is stubborn. If there's a rhythm, they'll measure it. If there's a rhythm, they'll look for it wherever there are clocks. That's why they're bringing in another line of observation, one that rarely makes it into pretty videos. Radio. Not images, but the behavior of the environment. Because if the impact was electromagnetic, it could leave a trace. Not necessarily everywhere. A hint in one frequency range is enough. They look at the data that usually appears in the background and find a short scar in the same time interval. It's small, but oddly even in shape. It doesn't look like interference from household sources. It doesn't look like a satellite in transit. It doesn't look like typical ionospheric noise. It looks like a signal that appears and disappears. And now, the picture is starting to come together all too well. Brightness peaks on the object, rhythm in Hubble's service channel, a trace in the radio, and all in one window. This is where the third theory emerges, the most unpleasant one. It's not Hubble is broken or the object is emitting radiation randomly. It's the object did something directed at the moment of observation. This whole idea hinges on one word, one that no one wants to say, but everyone is thinking about: guidance. If the effect is targeted, it could have been calculated, and then the coincidence in time ceases to be a coincidence. It becomes the intersection of two systems, our observational one and his behavioral one. From here on, the story becomes very down to earth, because on Earth, people love rules, and the first rule here is simple: don't give reason to panic. That's why a new layer of explanation appears the next day. HST is an old device. Safe mode is standard. No contact with the object. Formally, everything is correct. But that's the problem. Formal accuracy sometimes obscures meaning, as well as a thick cloth obscures light. Meanwhile, those who can't stop digging inside continue. They take a moment of silence and look not only at what, but also at where the telescope was pointed. Because direction matters. If Hubble was looking at the point where 3I/ATLAS was, then the effect, if it existed, could have been related to the line of sight. And here's where a detail emerges that quiets the conversation. The telescope was indeed in the precise configuration for observing the object. Not near, not almost, exactly there. The next step is logical and terrifying. If the impact was along the line of sight, it could have been designed for the observer. Not the Earth in general, but a specific eye. So safe mode isn't a misfortune, it's a result. And then the question changes. Not why did Hubble shut down, but why was it allowed to turn on before this moment? Another strange pattern has just been discovered in the network of ground stations. Several hours before the main window, the object showed consistent changes in the direction of the jets. Not chaotic, not sometimes stronger, sometimes weaker, but as if someone were moving the corner step by step, pausing, then moving it again, pausing. It looks like a sweep, like a scan of space, where each turn is a choice of direction, not a random burst. And now everything begins to sound different. If an object scans, it could see observers, not with its eyes, but by their impact on the environment. Because telescopes and radars don't just look, they emit, receive, and generate activity. Even passive imaging leaves traces in how the infrastructure operates, and if the object has sensors, it can distinguish silence from "we're measuring you." It doesn't necessarily have to understand us, it's enough to sense the mode. That's why one phrase, spoken almost as a joke in one of the chats, sounds like a death sentence. He doesn't react to the sun, he reacts to us. After that, no one argues about the words. Everyone argues about the next window, because if safe mode happened once, the second time might be different. This time, some teams propose a plan. Don't put all your eggs in one basket. Spread out your observations so there's not just one eye in charge. In parallel, someone suggests doing a test that looks too simple to be scientific, but too clever to be ignored. The test is this. Change the observation mode abruptly and synchronously, and see if the object's behavior changes at the same moment. If the object is just a comet, it doesn't care. If the object reacts to being observed, it may blink in response. Synchronization is scheduled for a specific minute. Teams in different countries simultaneously change settings. Some switch to a different filter, some change the exposure, and still others switch the device to sensitivity reduction mode. The minutes drag on like glass. Everyone stares at the charts in real time, and they're waiting not for a pretty picture, but for a reaction. The reaction comes. Not everywhere, not loudly, but enough to make my fingers feel cold. At two sites, a sharp drop in the object's brightness is recorded for a fraction of a minute, followed by a return. At the third, a brief shift in the tail structure appears, as if the beam had changed angle. From a scientific perspective, this could still be explained by 100 different reasons, but from a human perspective, it looks as if the object noticed that we pulled the handle. And then, late in the night, a new line of conduct emerged within NASA. Not a ban, not an order, but a silent tightening of the reins. Access to some logs is being cut off. Discussions are being moved to closed rooms. Public responses are becoming even more sterile. This isn't proof, but it's a symptom. When everything is fine, there's no need to clear out the space so quickly. Meanwhile, Hubble remains in the shadows, and every hour of silence adds not peace, but the feeling that someone is deliberately holding the pause. Because safe mode isn't just a switch, it's the time when you lose your most sensitive data, and if someone wanted to wait out those sensitive data, they chose the perfect way. The worst part begins when one engineer, after the initial check, notices a strange detail in the sequence of events. The command to put the telescope into protection mode came not after the first failure, but after a series of warnings that worked like steps. It feels like a test, as if the system were first hit with a weak impulse, then a stronger one, then even stronger, until it became clear that the protection would work reliably. And then a picture appears in my head that's hard to dismiss. The object seems to have tuned itself to the telescope's threshold. He didn't strike immediately, he didn't knock it out. He gently brought it to the edge, forcing the telescope to choose its own defense so that no one could say, "We're under attack." This is the purest scenario if you want to remain invisible in the legal sense. You didn't hack them, you simply made them shut down on their own. And if this is even half true, then the whole story of a normal glitch becomes not funny, but dangerous. Because then we are dealing with a system that understands our rules better than we are willing to admit. And at this point, history takes on a new purpose. Not to capture a beautiful shot, but to capture what lies behind the pattern. Catch the replay. Catch the signature of the impact. Catch the connection between the flashes on the object and the reaction of our systems. Because if the signature is repeated, the dispute is over. Not for the public, but for the decision makers. And the next step is already planned. Teams on the ground are preparing a double experiment. 2 windows, 2 different configurations, 2 different modes. One is keep quiet and watch. The other is change the mode synchronously. And we compare how the object changes. And in space, Hubble remains silent. And this silence speaks louder than any press release. Because silence at the right time is always someone's choice, even if it's called a simple glitch. By morning, a short message arrives, the kind that usually sends cold chills down people's spines. We're trying to exit safe mode using the standard procedure. The window is short, ready in 10 minutes. And at that moment, everyone realizes that this isn't about the picture. They're not launching Hubble for aesthetics or publicity. They need telemetry. They need an answer to one question. Was this a random failure or a reaction to a specific configuration, a specific pointing, a specific look at a specific point? The launch procedure only looks boring in a textbook. In reality, it's like reviving a patient who's already fallen once, slowly with pauses, checking every sensor, which tends to remain silent until the very end. That's why the first few minutes pass quietly. Nutrition is stable, temperatures are normal, threshold values are far away. Almost nothing happens on the screens, and this is the most dangerous state when the brain begins to believe everything is fine. Then the engineer watching the service channel doesn't raise his voice. He simply writes in the general chat. The step pattern appears again, same interval, same rhythm, and the silence inside becomes thick as concrete. This isn't a glitch, it's a recurrence, and a recurrence is worse than any one-time glitch because a recurrence implies a condition. If a condition is reproducible, then it can be triggered, and if it can be triggered, then it can be controlled. They do the first thing all reasonable people do in such a situation: remove the object factor from the line of sight. They turn the telescope slightly to the side, toward the control field, where there's nothing interesting except a stable background. For a second, it seems the pattern is disappearing. The channel is leveling out, the thresholds aren't twitching. Someone even mutters a dry, maybe it's a coincidence. But this hope lasts only until the next step, until the moment when the guidance is restored. As soon as Hubble begins to look again where it should have at the most crucial hour, the rhythm returns. Not immediately, not abruptly. First, 1 weak pulse, then a second, then a third, as if someone is probing the boundary again. And here's where the worst happens. The protection isn't triggered by overheating or power supply. It's triggered by a combination of signals that, while not catastrophic in themselves, taken together, appear to be an impossible combination, as if the device is seeing two different environments at once. Technically, you can call it whatever you like, but the meaning is very simple. Hubble is getting scared again, and so it retreats into the shadows again, choosing the only option that guarantees survival. The only difference is that now they have a control experiment. In the empty field, everything was calm. At the facility, everything repeated itself. And this isn't just a matter of an old telescope. This is a matter of there's a trigger. The most frustrating moment comes when one of the seniors says a phrase that's usually left unsaid. If the trigger is linked onto line of sight, then we don't just have an object. We have a source that interacts with the observation. No one wants to be the first to call this a response, because the word response implies dialogue. And dialogue is no longer astronomy, it's already contact at the behavioral level, and so they're switching to what can be done without direct sight, to radar and passive networks that look not at the image, but at the impact on the environment, the plasma, the ionosphere, and background noise. Quiet giants begin operating on Earth, large dishes that don't make the news but hold half of scientific reality. And on that same day, ground stations detect a brief shift in the spectrum that coincides with Hubble's attempt to return. The coincidence sounds innocent until you look at what exactly has shifted. It's not the brightness or noise that's changing, it's the structure that's changing. It's as if an organized element, previously background, is appearing in the signal. If this were a one-off, we could argue for a week, but this is the third time something organized has appeared in the seconds when we change our observation mode, and then the team comes up with a new idea, almost audacious. They decide not to hide, but rather to provoke, not in the sense of an attack, but rather a pure test. They plan a synchronized ping. Several observatories in different parts of the world simultaneously change modes, as if signaling through their behavior. It's not a beam, not a message, not a loud gesture. It's a subtle thing that only those who know how to notice such things will notice. They change filters, they change exposures, they change the schedule down to the second. They do it in such a way that chance can't explain the coincidence, and then comes the moment that people will later remember even the smell of the room. At the appointed minute, the four platforms make a synchronized shift, and a few seconds later, the object reacts as if someone had brushed against it with a shoulder. First, one telescope detects a short step in the tail profile, as if the jet were changing angle and then immediately returning. A second telescope detects a dip in the core's brightness for a very short period. A third telescope detects the appearance of a fine structure that wasn't there a minute earlier. This isn't a wow effect for the public. It's a nightmare for scientists, because the nightmare isn't the loudness of the event. The nightmare is the correlation. Too pure, too synchronous, too similar to a reaction to the very fact of our coordination. An internal debate begins that doesn't sound like an argument. It sounds like an attempt to survive in reality. Some say it coincided with a change in the solar wind. Others respond, then why did it coincide exactly with our ping, and why did it work at different latitudes? At the same time, they're raising things they usually save for later. Plasma data around the object, indirect signs where traces of interaction with the environment can be seen. And then another oddity emerges, quiet and very unpleasant. It's as if the shell around the object changes during our synchronized actions. Not a physical, invisible one, but one calculated from signal distortion. It's as if there's a zone around it that behaves not like dust and gas, but like an organized structure. This is where the word shielding comes in, and it sounds like all dangerous words. Fine if you're an engineer. Scary if you realize what it means for a regular comet, because shielding isn't about ice. It's about a system that can reduce exposure and manage leaks. It's about an object that doesn't just lose matter, but distributes it according to its intended purpose. And then an obvious yet terrifying thought arises. Safe mode might not have been a side effect. Safe mode might have been the goal, not because it was the enemy, but because it meant don't show what I'm doing right now. If an object has modes, then it also has moments when it's active in a different way, moments when it doesn't want to be measured in detail, and the most convenient way is to have the most sensitive eye close itself. Events then begin to unfold according to an unstoppable logic. If Hubble can't be used directly, then the bet is on a network. Many eyes, each weaker individually, but stronger together. They divide up the tasks. One telescope handles photometry, another the spectrum, and a third polarization. A pair of radio stations monitor the environment. Several teams prepare quick switches to test the reaction again, but differently, and then another layer appears, making the story more dangerous. Gaps begin to appear in the open data, not because there's no data, but because it's being held back, not published immediately, not made publicly available, not because it's bad, but because it's sensitive. It always looks the same. First, a small detail disappears, then the delay becomes regular, then messages like quality check in progress appear, and it's at this point that the public-facing part of the story becomes no less important than the scientific one. Because when data disappears, people start making up stories. And making up stories is always worse than the truth, even if the truth is alarming. But decision makers aren't thinking about panic. They're thinking about control. And yet, control cracks when another detail appears in private channels. Someone on the ground crew notes, "We see a repeatability in the jet angles." The pitch is almost identical. The pause is almost identical. This doesn't look like degassing. This phrase brings us back to the most unpleasant part, to the scanning mode, when the spikes are not random but consistent, when the object seems to comb the space, changing direction with a steady pace. If this is a scan, it might not be aimed at the sun or the void. It might be aimed at us, at our orbit, at our environment, at our technologies, at what we leave behind. And then safe mode becomes an element of the sequence. It's as if the subject has checked who's looking, how they're looking, and what they're looking with, and he's manipulated one eye so that it closes. The scariest part isn't that Hubble shut down. The scariest part is that it shut down correctly. It did exactly what it was supposed to, as if someone had already known where its threshold was and how to make it work. Inside the network, everything changes overnight. Previously, they hunted for beauty and detail. Now they hunt for causality. Not what's visible, but what triggers a reaction. And this is a different way of thinking, colder and more dangerous. Publicly, NASA says exactly what it always says when an old spacecraft fails. Entering safe mode, standard protection, recovery in progress. The wording is smooth, without unnecessary verbs, without any hint of a connection to the observational purpose. Internally, a new regime is emerging, not officially without written orders, but everyone senses it. A regime where any correlation is considered a threat, and the threat here isn't to people, but to truth, because truth can be lost with one wrong step. The most disturbing thing is that Hubble repeated the pattern again. This removes the romance of randomness and leaves only one thing, a trigger. When you have a trigger, you either carefully look for it or it starts looking for you. The first hours are spent on simple verification. What exactly was common between the two attempts to launch and return to the object? Guidance angle, exposure time, onboard buffer load, communication mode, even the command sequence. They're creating a map of dangerous combinations. There's no such thing as scary on this map, only chains of actions. But the fear is evident on their faces. It's not a mystical fear, but an engineering one. We don't understand what's breaking the system. The network of ground-based telescopes, previously a backdrop for space telescopes, suddenly becomes the primary focus, because Earth can't be sent into safe mode with a single command. Earth is noisy, stubborn, and it sees in different ways. They set up their observations so as not to give the object a single gaze pattern. One section of the spectrum, then another, a change in polarization, a frequency shift, different cadences. It all seems like a careful game, not letting it get used to it. And it's precisely in this game that the next coincidence arises, a truly ugly one. At moments when the network switches modes synchronously, the scanning pattern of the jets becomes slightly sharper, as if the step in the sequence becomes more confident. It doesn't look like more powerful, it looks like more precise. It's as if the object isn't being amplified, but rather adjusted. And this adjustment is more frightening than any flash, because flash can be capricious, while adjustment is a process. At some point, someone on the team says something they usually keep to themselves. If he's responding to our coordination, then he's somehow seeing our coordination. And for a second, the room goes incredibly quiet. Because sees, in this context, isn't about eyes. It's about the fact that every activity we do leaves a trace. In the radio spectrum, in schedules, in data transmission patterns, in how we synchronize time around the world. And if an object near Earth truly functions as a probe, then it doesn't need to look at us optically. It only needs to hear the environment, the planet's internal music, which we ourselves have amplified with our technology. After this, even the tone of the correspondence changes. Jokes disappear, unnecessary words disappear. Everything becomes short, like commands on an emergency panel. Don't publish anything raw. Check timestamps. Spread the wording across communication channels. Something else is happening at the same time, noticeable only to those accustomed to living in data. A delay appears in the public archives. A couple of sets of observations are moved to the under quality control status and remain there for an inordinate amount of time. Officially, this is normal. In the life of science, there are always checks. But people who work in real time know when a delay coincides with a busy window, it's no longer just quality, it's control. And then something almost comical happens, if it weren't so grim. Social media starts discussing what NASA is hiding. The public, as always, smells smoke, even without seeing the fire. And this noise begins to weigh on the teams more heavily than the object itself, because you can't tell them the truth if they don't understand it themselves. And saying, oh, we don't understand is almost impossible for large structures. Large structures are good at saying things like in progress, under control, and within normal limits. The internal emergency meeting is held without fanfare. It's not a press conference, not a briefing. It's technical, dry, with agenda items that don't mention fear at all, yet every word reeks of risk. It was on this call that the first thought that arose was enough to give scientifically inclined people a headache. We need to separate two hypotheses, hardware vulnerability and external influence. And do this without a third accident. There, almost in a whisper, they add another thing. If there is an external influence, it may not be intentional. It could simply be a field, simply a structure, simply an interaction with our line of sight. And this is an important point because it restores rationality. Not they see us, but the environment is designed in such a way that, given a certain geometry, it breaks the apparatus. The only problem is that the geometry is repeated too beautifully. It's too beautiful to be random. It's too in sync with the way the object changes its emissions. And it hits the window too precisely when observation is most informative, as if someone is cutting off just the right seconds for us. After a phone call, they decide to do something unpleasant but logical, reduce their focus on Hubble, and shift their attention to independent channels that don't have the same vulnerability profile. This is where serious ground-based arrays come into play. Long baselines, radio astronomy. Not a picture of the core, but a picture of the tail as a plasma structure. Not what it looks like, but how it behaves in the field and flow. There are no beautiful shots in this data, but there is something that cannot be faked by chance, consistent repetitions. And if there is a repetition, it can be measured even when the optics are silent. And this is where oddity number 2 comes in, no longer directly related to Hubble. Several stations are recording a brief dip in the background, as if part of the spectrum is jammed, for a few seconds, and then everything returns. This doesn't look like terrestrial interference because the dip is synchronous across different continents. It's not perfect, with micro shifts, but it's too close. And these micro shifts fall within the same time frame as the jet scanning step. When such things coincide, scientists go into a bad mood. They stop arguing, I believe it or I don't believe it, and start testing what such a pattern could physically produce. Plasma, yes. Magnetic structure? Possibly. A dust tail with occasional ejections? Weakly explains the synchronicity. Any solution hinges on one thing. There must be a system that maintains the rhythm. And here comes an idea that makes even those who enjoy a risk uneasy. Not just observe, but test the reaction, again, but without optics, without direct aiming, without that very trigger. The test is simple in form and brutal in meaning. They alter data transmission and time synchronization modes on terrestrial networks, so that to an outside observer, it appears as an intentional pulse. If the object is truly listening to the technosphere, it should notice the pulse, and if it does, it can either ignore it or respond by changing its modes. In either case, it will be information. The pulse is initiated quietly without unnecessary leaks. And over the next few minutes, a thin, narrow band appears on one of the areas of the tail's spectrum, lasting exactly as long as the pulse lasts, and then disappears. No one's shouting or celebrating, because this isn't a victory. It's confirmation that a connection is possible, at least at the level of correlation. And correlation is a door you yourself have cracked open. And just at that moment, as if following a script no one had written, another Hubble message arrives. Recovery delayed. Reason, need for additional risk assessment. Publicly, this can be sold as caution. Internally, it reads differently. We don't want to lose them again right now, and if they don't want to, it means they already know the risk isn't just technical. December 25th brings not a new sensation, but a new pattern. The orbit, refined using fresh astrometry, ceases to look like a flyby and begins to look like a route. Not a straight tangential shot. Not a random arc that could be explained by gravity alone, but a careful sweep around the perimeter, as if someone were outlining the outline of the zone. It's not even the distance that's frightening, but the geometry. The line isn't just smooth, it's logical. It moves as if the object avoids some angles and chooses others in advance. This is immediately apparent on the screen if you remove the fancy graphics and leave the raw measurement points. The points form an arc that avoids the convenient directions for observation. Convenient in our sense, where it's easiest for Earth to keep a target in its field of view, where radars offer maximum sensitivity, where optics have the best background. That is where we are stronger, and it's precisely there that the trajectory appears as if the object is trying to avoid giving us an ideal window, but also not completely disappearing. It doesn't feel like an escape, it feels like control. Like working within the limits, remaining visible only as much as he needs to be. Within the network, it's called by different names, but the meaning is the same. Perimeter, border route. None of the words sound scientific, but everyone understands them, because scientific words end where the motive begins, and motive isn't written in formulas, it's read from behavior. At the same time, what previously seemed like minor quirks begin to emerge. The jet scanning mode ceases to be a rare whim and becomes a rhythm. The emissions change direction at regular intervals, not chaotically, not randomly. Rather, it's as if the object is methodically combing the space in sectors. Each step is the same length. The pauses are the same length. The rotation angle is the same magnitude. This isn't degassing, it's a program. If it were just one telescope, we could smile and say, recalibrate. But this is what different instruments see, on different nights. And this is where Hubble comes into play again. Its absence isn't just a bummer, it's a hole in precisely the places where independent optics are needed, because the ground-based network provides a lot, but not everything. It creates atmospheric noise, it's dependent on the weather, and it doesn't like the fine structures of the tail, but Hubble loves it, and it's not there just when the first smart arc appears around the perimeter. During the next internal meeting, no one says the word intervention out loud, but everyone starts talking as if the word is hanging over the table. They compare the windows where Hubble slipped into safe mode with the windows where the object should have been best seen, and the match seems too perfect. Then they add another layer next to it, the timing of the scanning steps, and it turns out that the steps often fall at moments when the ground networks are most synchronous. When we work as one ear, when stations synchronize their time, when networks transmit data in packets according to the same schedule. If an object senses our pulse, then synchronization acts as a beacon for it, and it adjusts its scanning to this beacon, as if testing its reaction. It sounds crazy, but it only sounds crazy in conversation. In the data, it looks simple. A pattern is visible where there shouldn't be one. Next comes the step they dread most. They try to deliberately break their own synchronization and see if their behavior changes. The network is uneven. Different stations have different cadences, different spectrum bands, different intervals. The pulse is disappearing, and on the same day, the pattern of the jets becomes less distinct. It doesn't disappear, but it loses its Swiss precision and resembles more noise. No one is celebrating because this is confirmation. Confirmation that the object isn't simply emitting gas, but is responding to the observation structure. That is, he doesn't see us, but what we do. And in this logic, perimeter no longer seems like an artistic metaphor. The perimeter becomes a strategy, staying on the edge of our best abilities, forcing us to see but not allowing us to see perfectly. And against this backdrop, another layer of events begins to unfold. This time, not in space, but on Earth, where everything is already unstable and noisy. On different days, and in different regions, anomalies begin to coincide, which individually can be attributed to season, climate, tectonics, and ordinary chaos. Somewhere, storm warnings are sharply intensifying. Somewhere a series of small earthquakes are occurring. Somewhere the magnetic field suddenly fluctuates. If you look at it like a normal person, it's just a bad week. But if you live in correlations, you start to superimpose one thing on another. And the most unpleasant thing is that some peaks in time lie close to the scanning steps and to those sections of the trajectory where the object passes along the perimeter. It's not enough to call it reason, but it's enough to stop saying coincidence with confidence. A dispute arises within the team. One group says, the Earth is not a laboratory. You see patterns where there are none. This is an honest position. The other part replies, yes, but we have to check. Because if it is an influence, it may not be intentional, but it could be real. And then a third, even worse, thought arises. Even if an object doesn't do anything intentional, it could simply be the source of a field or flow that alters the environment. It doesn't attack or control. It simply passes nearby and its physics interacts with our magnetosphere, the solar wind, and the plasma. It still sounds like science fiction, but it's a different kind of science fiction, an engineering kind. Like, we didn't think this was possible until we saw it. And again, they run into the problem of evidence. The optics are incomplete. Hubble is silent. The data from ground-based networks is mixed and the noise is high. So we need a single indicator that's hard to confuse with terrestrial randomness. One signature feature that can't be measured by the weather. And such a sign appears unexpectedly, where it's least expected. In radio observations, where one array detects a short, repeating dip. The gap doesn't look like an obstacle, it looks like a cutout piece of the spectrum, neat and smooth, as if someone made a hole and then put it back. The dip itself could be an artifact, but then comes a message from a second station on another continent. We see something similar, with a slight shift, and then the third, and I no longer want to believe in coincidence, because the geography is different, the equipment is different, but the shape of the sinkhole is almost identical. They begin to search for a common denominator, and the common denominator is found in the sky, in the object's position, and in the perimeter portion of its trajectory. That is, at the moment when it walks along the border of our best windows, along the border of our strong lines, along the border of how we can observe it. And during this same period, Hubble telemetry resurfaced. Not new press releases, but rather dry internal load and error graphs. There's a repeat, not identical, but similar. Short bursts on one channel, then a break, then safe mode, as if the protection is triggered by a single type of event. The event doesn't look like a part broke. It looks like we received something unexpected at the input and responded as the device is supposed to. And if this something coincides in time with the radio dips, with the scanning steps, and with the trajectory perimeter, then the chain becomes too dense. Then they make a move that can't be reversed morally. They bring up old decisions that are usually kept secret. How exactly Hubble is protected from external influences? How does it react to radiation events? What thresholds are set? What sensor combinations can initiate safe mode? And there's something there that makes the room colder. It's triggered not by a single sensor, but by a combination, as if the device had detected a pattern. Not many particles, not a strong impact, but a sequence that resembles a signal or impact structure. This could be explained by rare space weather. It could. But then the question is, why does this space weather occur at precisely the right time and close to the object? A previously ignored phrase is finally appearing within the network. Perhaps it creates conditions in which our instruments see things they're not prepared for. And this doesn't sound like a conspiracy theory, it sounds like an engineering deduction. If the input changes, the output breaks. And then comes the most dangerous question. If it can change the input for devices, then it can shape the environment around itself. And if it shapes the environment, then passing along the perimeter isn't just a trajectory. It's a way to keep the Earth within a specific interaction zone. It's as if he chooses when to touch with our field and our noise, and when to retreat so that we can seek him out again, synchronize again, turn on the networks again. And just then, a short message from one of the ground-based optics teams arrived in the emergency chat. The sequence of frames shows a shift in the jet pattern by pitch. The shift is small, but it coincides precisely with the change in our synchronization. That is, the object doesn't simply cycle. It reacts to how we've arranged the cycle. They don't notice this shift right away because it's too small to be noticeable. But it's precisely these small shifts that undermine confidence the most. If it's nature, it doesn't adapt to our schedule. If it's a system, it thrives on these very small adjustments. A simple chart appears on the table. When the network is synchronized, the jet steps are even. When the network spreads, the steps widen slightly, then tighten again, as if the object is searching for a new rhythm. It doesn't stop the cycle. It adjusts the cycle to a new reality. The most disturbing thing is that this doesn't seem like a now it's hotter, now it's colder reaction, but rather a response to structure. It's as if he's distinguishing not intensity, but order, not the strength of the observation, but its form. This isn't the physics of ice anymore, it's behavior. At this point, someone calls it weakness testing. The phrase sounds childish, like something out of a game, and therefore irritating. But after a minute, it becomes effective because there are no other words. The perimeter ceases to be a line in the sky. It becomes a testing route. They take a radar window map. Not a pretty one, but a technical one. It shows where the Earth has the best geometry in terms of range, angles, speed, and background, and they see that the smart arc avoids these zones as if it deliberately doesn't provide the ideal set of parameters. It doesn't go away completely, it doesn't vanish, it remains nearby, but at an angle where the noise is greater, where the margin of error is higher, where any oddity is more easily dismissed as an artifact. It's the perfect position for an object that wants to be noticed, but doesn't want to be understood. Added to this layer is another, almost humiliating for science: social noise. While debates rage within, snippets of information begin to circulate outside. Hubble has fallen again. NASA is hiding something. The comet is acting like a spacecraft. And here comes the risk they fear more than the anomaly itself. It's not that the object is strange, it's that the world will react before they can explain what exactly is strange. Panic doesn't require proof. A hint is enough. One department suggests a simple strategy: ignore. Say nothing until you have the hardware. The strategy is logical, but this time it breaks down because the information field is no longer empty, it's noisy. Instead of emptiness, a vacuum emerges, which is quickly filled by other versions, and each subsequent version becomes louder because it is not constrained by any real data. On the next call, someone quietly says, if we say too little, we'll be blamed. If we say too much, we'll be forced to answer questions we don't know. And that's true. But the truth doesn't help when the window of opportunity is already closing. Meanwhile, ground-based observatories are doing what they always do when they're scared. They're working harder. They're trying to close Hubble's hole with quantity. More frames, more filters, more different wavelengths. And it's at this moment that the object, as if sensing the acceleration, makes a move that seems overly demonstrative. The pattern of the jets becomes clearer, and for the first time, it forms not just a simple pattern, but an almost geometric design. Not a drawing for beauty,